So today we're going to talk more about changing fractions to percents. So in this example, we've got Lila wants to rewrite 10/25 as a percent. She decided to represent 10/25 in a picture that looks like this. She took a square, divided it into 25 smaller squares, and shaded in 10 of them. So she went through this process. And let's go through it together. How many sets of 25 does she need to make 100? Yes, need 4. So then how many sets of shaded squares will she need? The same. She'll need 4 of those. Now, the question is, how many total shaded squares will she have? Well, she had how many? 10? She's going to make 4 sets of those, so that's going to be what? 40. Lila drew the picture below, and then she wrote the equation on the right to represent her work with the shapes. So she said, I took this, I multiplied it times 4, which gave me something that looked like this. When I do that, I've got 40 shaded squares out of 100 squares. Then when Lila multiplies the number of shaded squares by 4 and the total number of squares by 4, does the amount of shading compared to the total squares change? The answer to that is no. This is a little bit like if you have a deck of cards and I ask you, what's the probability of pulling out an ace? Well, there are 4 aces out of 52 cards, right? What if I shuffled in a second deck and said, what's the probability of pulling out an ace? Well, it's now 8 out of 104. But isn't that just 4 out of 52? Which reduces to 1 out of 13. Okay, they're the same. If you double the sample space, as long as you double all the categories within the sample space, the proportion doesn't change. Your probability doesn't change. So the proportion doesn't change if we have 4 times as many total squares and 4 times as many shaded squares. Now, that explains it in terms of a picture. In terms of mathematics, you have to understand that multiplying a number by 1 doesn't change its value. Right? If I multiply 7 times 1, I get 7. If I multiply 12 times 1, I get 12. If I multiply 463.2 times 1, I get 463.2. Multiplying by 1 does not change that. So when the numerator, remember that's the top number, and the denominator, that's the bottom number of a fraction, are multiplied by the same number, some people like to say that the fraction is multiplied by a giant 1. By some people, they mean the authors of the textbook. They're the ones who decided that we should call this a giant 1. I have a former colleague who called it a fufu, which stood for a fancy form of 1. Okay? In any case, this is what it looks like. They're taking the 10/25 and multiplying it by 4 over 4, which is just another form of 1. So is this value, is this proportion different than this one? Are they different? Absolutely not. Do they look different? Yes. Yes, Ben. Yes. Let's try and go between classes, gentlemen. So why is the fraction 4 over 4 called a giant 1? Well, because four divided by 4 is 1. And the reason it's called giant is because we didn't just write 1. So maybe we can put giant in quotes. It's giant because we didn't just write 1. We wrote, again, what my colleague would call a fancy form of 1. And you may not believe this, but this idea, we used it in calculus today. Okay, this idea is a super important idea in math. It comes up all the time. The form of 1 gets way more complicated later on. For now, you just put one number over the same number. So each fraction below is next to a giant 1. Multiply the expressions to rewrite the fraction. If you haven't already done so, go to it. So please do both A and B on number 2. If you've already done that, check with someone who's sitting nearby you. Don't let your neighbor be wrong. Ben, your neighbor is to your side. Ben, your neighbor, you're excluding him, man. That's not cool. Yeah, you can choose someone in front of you or someone behind you. Okay, Bella, can you tell me what you got for this one? I'm good with the 150. I'm not so good with the 56. 54, okay. I was going to get on your partner. You're supposed to make sure your partner's not wrong. All right. And then desk 9. Barrett.
1845.
Yep. So this is a way of rewriting fractions. It's the opposite of reducing a fraction. And you may be going, well, why would I, not want to reduce? Well, if you're getting a common denominator, this is what you did. You did this on last night's homework. Okay? Let's move on to page 2. Sometimes you've got to think about, all right, what number do I want to use in order to get to fill in the giant 1? So like on this one, for example, it almost rolled all the way back. If you've got 5/7 times, we want this fancy form of 1 to be 40 over something. What do I need to multiply by? Callie. What? I'm sorry, did I say it wrong or?
It's
It's Kaylee. I'm so sorry.
8 over 8.
Yeah, we're going to multiply by 8 over 8. Very nice. And anybody, 7 over 8 is?
56.
56. Oh, no, we're not there yet. It's interesting that happened to you. I actually talked about this in calculus the other day, that one of the things that gets me in trouble is when I'm doing a problem, sometimes I anticipate what I think they're going to ask, and then when they ask something else, I'm totally wrong. Okay? All right. So, were you really wanting to answer this one? Yeah, it's going to be multiplied by 10 over 10. This is going to be 50 over 70. All right. So, using a giant 1, you can rewrite any fraction as a different fraction that represents the same portion of a whole. Fractions that are equal, but that are written in different ways, are called equivalent fractions. So, Adele, Carla, and Lisa are reading the same book. Each has read a different number of pages as described below. Adele has read 5/8 of the book, Carla has read 12/16 of the book, and Lisa has read 13/24 of the book. So, if we want to compare all three of these, let me call on somebody. 7. That would be Ben. So what denominator would be best for this, do you think?
I'd say 24 because 13 cannot divide down to anything.
Because 13 what?
Can't divide down to anything because it's prime.
Okay. So if this was 11, would it be different, or 10, or?
If it was, no, it can't divide by 8. So.
Okay. So I agree with you. I'm not sure that I totally agree with your reasoning. I didn't even look at the 13. Personally, Cooper, did you have an idea of why? Why 24? It's one of those ones where you just know it, and that happens a lot. It's okay. Why is it 24 perhaps best? Yes, ma'am. Oh, you were going to answer my next question? 16 can't go into 24? Oh, so...
Don't they all have to have the same denominator?
So...
Because
Wait, hang on. I can't listen to two people at the same time. So if you want to get them all to have the same denominator, 24 may not be the best choice. However, do we need to get all of them to have the same denominator to compare these? And I think that this is what you were talking about.
I was going to say,
Oh.
Go down with the middle one to go back up to 24.
Okay. Yes.
Wait, I think you just said the right answer.
Okay. So, did they all read over half of the book? Yeah, they all read over half of the book. So we can't just throw one of these out easily. So I would say 48 is a better choice for the denominator. What denominator could they use to compare the portions that they've read? 48. Is there more than just one? No, they could also do 96. They could do 192. There's a whole bunch. But 48 is the, who knows what that's called? I'll take a volunteer for that. What is that called? Yes.
common denominator.
You left off a word, but that's the second two words. Yes? It's the least common denominator. But you had the right idea, Cooper. We want a common denominator, and it's nice if we find the least one, because that's going to be the smallest. All right, so let's take this. So we've got 5 over 8 times, I'm never going to, or at least not very often, do this and write the big one because, well, it always looks wrong when I do it.
Looks like a spray bottle.
Looks like a what?
A spray bottle.
A spray bottle. Yeah, it does kind of.
Oh, it's like a soap dispenser, where you push down.
Looks like that.
Oh, yeah, it does look like that.
It looks like a car.
I want to take you guys out to look at clouds someday and see what you see in clouds. That would be fun. All right. So what do I need to multiply this by? What form of 1 in order to get this to be over 48? 6 over 6. So that's 30 out of 48. And for the 12/16ths, and I'm not going to write the 1 around it, what over what? 3 over 3. So that's 36 over 48. And then 13 over 24, what over what? 2 over 2. Thank you, Sammy. So that's 26 over 48. So which girl has read the largest part of the book? Carla. Good old Carla. And notice it says show work to justify your answer. This is the word. So I would be like, yeah, I accidentally did it up here. So let's look at this. Which of the events below is most likely to happen? Justify your answer by rewriting the portion in a different form. In each case, show your thinking with pictures or with labeled calculations. Real quick, with pictures, your book loves to do the pictures. I'm just way too lazy to do pictures. Okay? Now, my joke is that mathematicians are either the laziest people in the world or the most efficient people in the world. So when someone says, you're just being lazy, you're like, no, I'm just being efficient. Okay? So there are lots of ways that we could write these. Since we have a percentage, I'm not going to change them all to percent, but I am going to change them all into something over 100. That makes it easy to compare. So 78%, what is that? 78 over 100. That's just the definition of a percent. 4 out of 5. What form of 1 do I need to multiply by? 20 over 20. Yeah, and let's say 20 over 20, not just times 20. So that's 80 over 100. And then a 7/10 probability of picking a green marble. What form of 1? 10 over 10. So that's 70 over 100. So which of the events is most likely to happen? Teacher will assign homework today. Speaking of homework, you have it, and you have, I think, some time today, actually.
Yeah, we have a lot of time actually.
We have a lot of time? Nice. All right, so go ahead and get started on that. You can also be studying for tomorrow's quiz if you want to do that